Hi everyone, welcome to the tutorial for the MedicaidJS SDK. The MedicaidJS SDK is an easy-to-use JavaScript library that requires no downloads or installations. The library allows users to generate real-time visual analytics, analyze drug metric data, and also create data aggregation workflows. The library functions through three complementary APIs, and it fetches data from the Medicaid API, the RxNorm API. So what we're looking at here is actually the observable notebook that's associated with the MedicaidJS library. And here we can go ahead and find different demonstration, pre-built tools, and other documentation associated with MedicaidJS. So if you're just getting started learning about it, you should probably navigate to the observable notebook to learn more. Now getting into how we can actually install MedicaidJS. It's a very simple installation that can be done in any environment that supports a Node.js interpreter. So you can do this in a browser environment, or you can do it in any IDE of your choosing as long as you have Node.js installed. So I'm going to go ahead and look at this line of code. It's a simple import statement following the ES6 conventions of JavaScript. And all we're doing is we're just saving that import statement into a variable. So now I'm going to go ahead and navigate over to some documentation to learn more about what MedicaidJS actually does and how we can learn about using it ourselves. So I'm going to scroll down and simply go to Data APIs and Documentation. Here we are. So here we can see the documentation for all the functions included in the library, and this is an observable notebook. The advantages of using an observable notebook is that users can directly see function calls happening in real time, and they can even play around with the code that calls the functions and see the direct output. So this is a simple table of contents representing all the modules in MedicaidJS. If we simply select on Metastore, we can see some of the functions involved with that module. So Metastore is just a simple module that sort of outlines some basis of data retrieval for MedicaidJS. So as we can see, we have our list of methods, and then we have parameters and the purpose of the method as well. And we can also see the function call itself. And if I wanted to, I could even enter in a different parameter here. Let's say in this case, I wanted to do distribution. Here we are, and I just hit the play. And then I can see the outputs of that function call in real time. Okay. So you can go ahead and explore this on your own. You can look at all the modules and all the functions there, and then you can sort of learn more about what functions you're going to want to use from the library and integrate into your own workflows. With that being said, I'm going to go ahead and transition into a demonstration of how to install the library itself. I'm going to start by installing it in a browser environment. And how I'm going to do that is I'm just simply going to copy over the import statement we talked about earlier, and I'm going to navigate to any URL that doesn't have cores blocked. You should be good for most URLs that you use. But I'm going to go ahead and paste in our import statement directly into the console. Press enter. So this is our MedicaidJS library. And as you can see, I have the module nicely installed here. And these are examples of all the functions included in the library. So I'm just going to simply do any kind of function call. One of the functions that we saw from the Metastore earlier was getSchemas. We're just going to go ahead and call that for demonstration purposes. And here we are, it's actually saved for us. I'm going to go ahead and enter that. And as you can see, we get all the data that we wanted very, very simply. So just for some context about what this function is, it actually just gives us the data objects that are involved in the Medicaid API. So as you can see, we are fetching a significant amount of data every single call of a function we make. So where's this data actually being stored? Is it being stored at all? The answer to that is yes, it definitely is. In the back end, MedicaidJS actually interacts with local forage and the local forage API. And what this allows us to do is navigate the use of IndexedDB and other asynchronous browser databases. So this allows us for every single function call we make, we store the data in an asynchronous browser database where it can persist over time. And this allows every subsequent call of methods to be significantly faster, as we're not making any fetch requests anymore. We're just querying our database where we've stored the data. If you do want to consistently get fresh data every time, there is a solution for that. You can simply clear this database by calling the clear cache method. that would be this method right here. You can call this method, and that's going to directly clear out this database for you, so you can consistently get fresh data every single time. I will note that the library automatically has a cache clear feature where after a certain period of time, certain unused items are cleared from the cache, so you get fresh data the next time you use them. But if you want to get updated data every single time you call, you can simply call the clear cache method, or you can insert a parameter into some methods that offer it, saying that you don't want to cache that data. Okay, so with that being said, I'm now going to transition into demonstrating some of the visualization capabilities of MedicaidJS. So I'm going to navigate over here. So here I've just initiated a simple observable notebook, and in the first line of the code, I've just placed our import statement and saved it to a variable. So now I have the module right here. And I'm just going to be calling a couple different methods, and I'll talk through what exactly they do as we go through it. I'm just going to start off with this function right here. Oopsie. Delete that. And here we are. So we have a chloropleth map of the United States. And what we're doing is we're actually graphing drug utilization for Humalog, which is a diabetes medication. So we're actually able to visualize what states most heavily use diabetes medications like Humalog the most. And we can see that New Jersey and I guess Texas are some of the highest users of this drug. So what's being happening here is in the function call is we're actually inserting what's called an NDC. So all drugs, in addition to their name, have an NDC, which is a national drug code associated with them. So we can graph drugs based on their name or these NDC codes. In this case, we're graphing obviously based on the NDC code. And then the second parameter is just an object containing some different information about some graphing parameters. As you can see, the first parameter is an outliers parameter that's set to true. One of the cool features about this specific method of plot util map is that it includes an interquartile range analysis feature that actually filters out outliers if you select true on that. So in this case, what we're doing is we're actually filtering out some outliers in the fourth quartile and the first quartile in order to actually better be able to see the variance. If you say, hey, I want to see all the data anyways, don't filter out any outliers, no problem. We can simply turn that into a false value, and here is the output when we go ahead and actually don't filter any outliers from the top quartiles and the bottom quartiles. And we can see we have a slightly different graph where New York and California are among the highest utilization. The only nuances between these two is that you can't really see as much variance in the data just looking at it in some of these grayed out states and some of these, light purple states, which is a reasoning for why you may consider using this interquartile range analysis to filter the outliers out. So this is just one type of graph that we can generate with MedicaidJS. We can also generate time series of both cost and volume for drugs. And I'll go ahead and indicate that for you. So this is going to be a simple time series comparing cost over time of two diabetes drugs. One is Ozempic, and then one is also Humalog that we were looking at earlier. And we can see we have the data for the cost per unit in dollars of these drugs over time. We can see that. Also do that too for both the same drugs. Simply for this method. And we can see the utilization over time for these functions. And the utilization here is specific in that you can compare the number of prescriptions and the total amount reimbursed for these drugs. So you can see a lot of different information from them, which is really useful. So that actually goes ahead and concludes our tutorial for MedicaidJS. If you have further questions or want to explore the library more, I would recommend that you go ahead and navigate to the observable notebook and explore that. If you encounter any errors with the library, please visit the GitHub issues section. Other than that, thank you so much for tuning in. I hope you enjoy the use of the library.